Is on page 8, and what we're doing is we're filling out the angles in degrees and radians in the first quadrant. They already did the first one for us. How nice. They also could put 0 degrees and 0 radians. Okay. What's this next one? Bless you. Pi over 4, or how many degrees? 45. Great. Up here? 60, or pi over 3 here. And pi over 2, yeah, and you always want that simplified. So if you use a road map and you change that, that's fine, but when you answer the question, you want to reduce it. Okay, this is what I mean by jump around. Let's go to this one, because if you jump around, you're going to learn these much faster. Now, this is the x-axis. Any of the angles that are closest to the x-axis are what degree with the x-axis? They're the 30s, so they're always the pi over 6ers, okay? Does that make sense? The ones that are closest. So if you want to do your road map in 6s and tell me what this angle would be. 5 pi over 6. Very good. In degrees, it's 5 pi over 6s, or 5 pi over 6s, or 5 times 30, which is 150. Okay? Now let's jump around a little bit more. Let's do this one. The one that's always in the middle belongs to what family? Pi over 4. So if I make my road map 4 pi over 4, could you tell me in radians what this one is?
5 pi over 4.
You got it, 5 pi over 4. And what are 5 pi over 4s? 5 times 45 is 225. See how that's like making your brain practice it way better than just going around and systematically grabbing certain ones. So let's do one more. Let's do this one. The one that's always the furthest from the x-axis in each quadrant is always the family of the pi over 3 is good, the 60 degrees. Great. So if I make my road map 3 pi over 3 and 6 pi over 3, this guy has to be 5 pi over 3. Okay, 5 times pi over 3. 5 60s is how much? 300. Okay, get the idea? So, I mean, you only have a few more to fill in, but part of the homework tonight is going to be doing that. And I want you to jump around. Now tomorrow, okay, so the last little piece that I'm going to teach you today isn't too bad, but I will warn you that it's, I think, 8 points on the test. So there will be 8 points just on this on the test. So what we're going to do are just some applications. We don't get into like a ton of applications like they do in honors where they talk about revolutions and they, you know, how far things have traveled. But we are going to do the most basic formula, which is this. S is r theta. What we need to know about this is r, of course, is the radius, okay? S is the arc length. So let me show you a picture. Let's say you have a circle, and this is your angle theta. The radius, of course, we know what that is. That's that. The arc length that angle, that central angle, cuts off. Sometimes they use the word subtends. Sometimes they use the word intercepts. But basically cuts off that part of the circle. That is called S. That is the arc length. Now what's really interesting is I can finally tell you what a radian is. Okay? How they get what a radian is. Anytime your radius and arc length are the same, it's considered 1 radian. And let me show you why. If you went all the way around the circle, what's that called? The circumference. What's the formula? 2 pi r. Okay. What if the radius and the circumference are the same? What if the radius and the circumference are the same? What would the angle be? I'm going to use this formula to show you a little bit. If I solve this formula, a radian 1 radian is when the circumference, or the part that's cut off the circle, and the radius are the same. What if you go all the way around the circle? The circumference is 2 pi r. What happens here? What would your angle be? 2 pi. Yeah, we know that, right? Because we've been saying 2 pi is how far around the circle. So how 1 radian is defined is when the arc length and the radius are the same. That's 1 radian. Okay? And you can see if I said, hey, the arc length's 5 and the radius is 5, what's 5 over 5? 1, which is 1 radian. Now the biggest mistake that we will make on this, we want to know S is the arc length, R is the radius. Biggest mistake we'll make, theta is the angle, but it has to be in radians. So if the angle's not in radians, you cannot use that formula. So put a star by that as you're studying. That's probably the biggest thing. That's the mistake that's normally made on the test. So we want to avoid that mistake. So let's try an example. A circle has a radius of 4. So what letter in the formula do you know? R. Good. R is 4 inches. Find the length of the arc. What are they asking us to find? What letter? Well, you only have 2 choices left. S or theta? S, because theta is always a what? Angle, so it couldn't be an arc length. So S is the arc length, intercepted by a central angle, angle's theta, of 240 degrees. I cannot touch that formula yet until I do what? Convert it to radians. So here's good practice. 240 degrees belongs to what family? 60s, right? How many 60s is 240? 4. So this would be 4. 60 is what in radians? Pi over 3. Yeah. So see how you're going to use that mental part, the old stuff. We're just building on it. So we have to change that angle. Now I'm going to use S equal R theta. I'm going to plug in 4 for the radius. I'm going to plug in 4 pi over 3 for the angle. And I'm going to multiply them together. Now if I'm allowed to use a calculator, or if I'm not allowed to use a calculator, I might leave it 16 pi over 3, because that's a better answer than the decimal approximation. This is the exact answer. When you do the decimal, it's just a rough approximation. Now I need units on this. What do you think the units are? Inches. The radius was in inches, and angle theta is really unitless. It's radians, but they're unitless. So our answer is in inches. Now if you really, really, really want to throw that into the calculator and get a decimal, you could. So on the test, you will be able to use your calculator, but it's not necessary. If you threw that into the calculator, just to tell you in case you are interested, that answer would be 16.76.
Well, close but not quite.
Yeah. So you'd have to do 16 times the pi button divided by 3. Okay? So then, just in case I got it wrong on the calculator, just leave it like that. Any questions? Is that example tough? Where are we going to make mistakes? Forgetting to change?
To radius.
Yeah.
Could
Mm-hmm.
you still set it up as like the 180 thing, or is it easier to just do
The 180 thing.
It was the one where when you're converting it to radians, you do 180 over pi.
Yeah, you could, but it's one that's on our unit circle, so we don't really want to do that.
Okay.
Okay. Yeah, if it's a multiple of 30, 45, or 60, we don't want to have to go through the conversion. Could you? Yeah, it'll give you the answer, but we should be able to do that without it.
Okay.
Okay?
But you wouldn't take off points if we did that on the test.
Well, you'll run out of time. Because you
Okay.
have to know, you know what I mean? You're
Yeah.
gonna, it's going to be a time crunch if you don't know those. And then when we go to graphing and solving and all the other stuff we do with it, then you'll be behind.
Okay.
Okay? All right, B, find the angle of the central, or find the measure of the central angle. What do they want us to find?
Theta.
Theta, good. With a radius of 9 inches, what letter do we know? R. That subtends, fancy word, cuts off an arc of 20 inches. What letter is that?
S.
Good. Okay, so I'm going to use that formula, S equal R theta. What are we going to plug in for S? 20 for R, 9. Beta is 20 over 9. What are the units?
Inches.
No.
Oh no, they don't have any.
Yeah, because what happened to the inches on both sides of the equation? They canceled. So it's unitless. Now, if you want to, you could write radians, but you don't have to because theta is unitless. Now, that's what I'd leave it as. Now, if you really wanted to use your calculator, because we're going to have to use it in a minute anyways, it's 2.222222 radians. Okay? But I'd leave it like that. Now, the question says convert it to degrees. All right. So how do I convert 29ths radians? Now we're putting some old stuff with this new stuff. How do you convert to radians? And this would be one back to your question, Anna, that we don't know what that is on the unit. It's not a multiple of 30, 45.
So you would use the one.
You would definitely use your calculator on this one. What would we multiply by? And we'd use the conversion.
180 over pi.
You got it, 180 over pi. Now let's say I didn't have a calculator. I could at least multiply the tops and multiply the bottoms. And couldn't I say the answer is 3,600 over 9 pi? But my question is, put in degrees, minutes, and seconds. Now we're combining another thing that we've done. See what you get. Some of you aren't going to get this right, and we want to talk about why.
Yeah.
You just have to be reminded of something. When you put 3,600 divided by 9 pi on the calculator, what do you have to remember?
Oh, I did it differently. I just did 2.22 times 280.
You don't want to round it. Do you, okay, so good question. You do not want to say 29ths is 2.22 because now you just rounded. Your calculator has the capabilities of keeping it accurate. So you want to definitely keep all those decimals. So remember how we talked about yesterday, just doing second answer DMS, and it'll take all your, yep. Why is someone possibly getting, let me tell you the answer that a lot of people will get, and you tell me why. Did anyone get 1,256? Yeah, what are we missing? Parentheses. Because if you're not putting parentheses over 9 pi, your calculator's doing 3,600 divided by 9, and then multiplying that answer by pi, which is, whoa, not what we want, right? So remember, these are like old math things, but on your calculator, it's a little, it's fussy. It does order of operations. So put parentheses around that. So when you do 3,600 divided by parenthesis 9 pi, you should get 127.323945, blah, 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 blah. Do we want to write that decimal down? No, not if they're asking us to go to degrees, minutes, and seconds. Just do second apps. Number 4, boom. It'll take all those decimals. Because if you just did, what number did you do? 2.22. And if you change that to degrees, minutes, and seconds, yeah, we're definitely not going to get the right answer. Okay? And I know there's one on the test similar to that, where they're going to give you this and ask you maybe to convert to degrees, minutes, and seconds. Any questions there? Okay, let's go over the homework. So last night's homework, we have 4 presenters. Those problems are listed on the board. So we'll start there, and then we'll see if you have other questions that you need to take a look at. Okay, so let's start with presenter of number 18.
So the problem wanted you, I believe, to find what quadrant the angles laid in. So it just gave you a number, which was in radians. So then I drew the little graph and the road map, and I determined 3.5 is greater than pi, but less than 3 pi 3 pi over 2. That should be 2. I wrote 3 for some mistake. So it's in the third quadrant. And then for B, it gave me 2.25. It's less than just pi on its own, but greater than pi over 2. So
Okay,
it's
so all
somewhere
you had
in
to
there.
do was sketch the angle. Yeah, you didn't have to do any coterminals or anything, so this one, he's just putting it there, and this one there. And I just wanted you to do more practice with those where they're decimals, because we tend to kind of get confused on those. All right, next one, number 24. Two more where you had to sketch, but they were just kind of weird ones, so.
Alright, so for A, we have the graph 2. So 3.14 is pi, so that's on the side. So 2 is a little less than in between 3.14 and 157.
Good.
157, so it goes there. And for B, you have to find 5 pi. And so you just go around twice because that would be 2 times 2 pi, so it would be 4 pi. And then go all the way around to pi again to make it 5.
Yes, very good. So for 5 pi, you go once, twice, and a half. So 2.5 times. Great. Okay, nice. Thank you. 71. These were on the stuff that we covered yesterday.
So you would just do, there is a small negative there, it's kind of hard
Ooh.
to see.
Okay, yep, there's a small negative. Good.
So you would do 125 degrees plus 36 over 3,600, and then you'd factor in the negative, and it would give you negative 125.01.
Okay, good. We need something or it's not going to be right. This is really good that he said, I'm going to hold the negative till the end, because some people do the negative and get negative 124 degrees. That's totally wrong. This will be on the test, so I want you to go over it. But what are we missing? Big, big, big. The what? The degree symbol, okay? So we needed the degree symbol, or it's going to be wrong. So just be real careful there, okay? All right, but the other part, the hard part, look good. Just throw that degree symbol in there. And the last one, 77.
Yep.
And then look to see if you have any other numbers. So looking through the other parts of the homework, see if there are any other numbers that cause problems. Giving you this one on the homework because there's one like this on the test.
Yeah, so pretty much I just took the standard equation thing and it's in radians, so I had to convert it into a degree. So I put the conversion conversion equation there. So I got it in 63 point, it's like a 9, yes, a 9, over pi equals 20.340, I think that's a 0. And so then what I did is slap that in degree, minutes, seconds, and I got 20 degrees, 20 minutes, and 24 seconds.
Okay, good. What do we need on here? We're going to miss it.
Negative.
The negatives, okay? So since it was negative all along, that's right. He multiplied these two numbers, which turned out to be a nice decimal, so that's okay. This did not turn out to be a nice decimal. So he didn't actually put in 20.34 and see what that was in DMS. He left that was, like if you did negative 63.9 divided by pi, you have negative 20.340017, blah, 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 blah. So using all of those digits, you'll get this. If you would only have done negative 20.34 and then DMS'd it, you might not get the same answer. So if you round, just be careful, okay? So this one was one where you would get the same answer if you stopped here. The one on the test, you won't. So remember yesterday how we used that A and S button? So what I do on the calculator is do negative 63.9 divided by pi, not even write that down, take that answer and do DMS. If not, you might run the risk of getting it wrong on the test, okay? Because you don't want to round. Any questions? Okay, good. What other numbers?
26 and 28.
26 and 28. So 26 and 28 were both coterminal problems. So the first thing we want to do is sketch them. So in 26, I have my road map. And then 7 pi over 6 is a little bit further than 6 pi over 6. So then the negative angle from 12 all the way around, I've taken off 7. So there are 5 left, 5 pi over 6 in the negative direction. Then the other positive one, go all the way around 12 pi over 6 plus 7 more, and that'll give us 19 pi over 6. Part B, when you sketch 5 pi over 4, that's going to be in the third quadrant. Using my road map, I know 8 pi over 4 is all the way around. If I've used up 5, I'm left with 3 pi over 4 in the negative direction. And then the second one, go all the way around to 8 plus 5 more to get 13 pi over 4.
So to find the second coterminal, you just go all the way around the beginning and then just add.
You have to find a positive. It depends. We saw one yesterday that was 13 pi over 6 originally. So we went all the way around, and then we ran into the coterminal. So when it was 13 pi over 6, we said, hey, instead of swinging all the way around again, I'll just take pi over 6. So we saw one like that. Was there a certain part of 28?
Yeah, it was just finding the coterminals I'm having a little bit of trouble on.
Okay, so do your road maps because that'll help, and then it's a matter of figuring out what's left from what they give you. That's the negative direction, and then this one, we're going to sketch it and then go all the way around.
Okay.
And this one worked out very similar, same thing.
Okay.
And those road maps really help, and it seemed like on the quiz, doing those road maps, people did so well on sketching them. What other numbers on the homework? Were degrees to radians a problem? Any other numbers on your list? Okay, so let me put up the book. This is right where you are in the homework. Here's the first one, and it's like the bottom of the book, so you got to write it down so I can put the other problems up. But the first problem tonight in the homework is number 87.